Okay, so you should have watched that video on conducting a hypothesis with that guy cheating in an exam. I just wanted to reiterate a couple of things. What is a hypothesis test? So we will always be looking at binomial hypothesis testing. So we will always be looking at maybe a proportion of things or a probability of something happening. In that case, it was the probability of guessing a question right is 25%, for example. And then some claim will surface, or maybe we just want to test that. We want to say, okay, someone's saying, oh no, it should be more than 25%, or oh no, it should be less than 25%, or maybe we just want to know, oh, is it just different from 25%? And that's what these three cases here are. So our alternative hypotheses then can be that the proportion is greater than the original. So again, that was maybe we were assuming, like that person cheating, that the probability of them getting one right, guessing one right, should have been 0.02 under normal conditions, but under maybe if they were cheating, then the proportion should have been higher. Same then for there could be just a less than, maybe, I don't know, a company is claiming that 80% of people use their product, and someone comes along and says, no, I think they're telling porcupines, I think it's actually less than 80%. Okay, we'll test that then. So the alternative hypothesis is always, okay, we need to check, maybe is it less than or more than the original. Alternatively, these should be sugar. These should be p's, not thetas, sorry. But again, our null hypothesis is always, yeah, the proportion is what we assume to be at the start, or the probability of success is what they say it is in the question, that it is, that he was just guessing in his test. And it could be then maybe that we don't know either way. Was it a greater than or was it a less than the probability? And in that case, that's when our null hypothesis is just a not equal to. We'll have a look at, I think that comes up in the second example, so you can have a look at that. Anyway, so hypothesis test for a binomial. Again, so what we'll do is we'll assume that the original proportion, the original probability is true. And we'll say, okay, let's just take a sample now. Let's just take a sample, a real life sample. Let's collect some evidence and see what happens. So we will be able to then, we'll have a number of things that we've collected, which will go into our binomial probability, along with the proportion or the probability that we would expect to come up. So that is under H naught. We could then find out how many of our things we would expect on average by multiplying those two numbers. What proportion of our sample size would we expect to come up? And then we can compare our sample value with what we would expect, and an extreme value of the thing that we are counting in comparison to what we were expecting, I would cast doubt on the likelihood of our null hypothesis being true. That means if we maybe are expecting 80% of people to be using fairy liquid, and if I asked, I don't know, 20 people, do you use fairy liquid? Then I would be expecting 80% of 20, so I would be expecting 16 of them on average to be using fairy liquid. Well, you know, it isn't always going to be spot on 16, it might be 14, 15, 16, 17, 18 of them, but around about 16 of them each time should be saying, yeah, I use fairy liquid, because I'm expecting 80%. Now, if I ask a random 20 people and I actually get, I don't know, only 10 of them say they use fairy liquid, well, that's actually quite a lot smaller than 16. So what I do then is I look at working out the p-value. I say, okay, what is the likelihood of me getting what I just got? What is the likelihood of only 10 people, or maybe even smaller, maybe even further away from what I was expecting? What is the probability of that happening? What's the likelihood of my sample happening if fairy liquid are telling the truth, that 80% of people use fairy liquid? And if that probability, that's my p-value, if that probability is so small, if it's so unlikely to occur, well then H0 probably isn't true. This proportion here probably isn't correct, and I probably should have been expecting less in the first place. I don't know how much I should have been expecting, whether it was 70% or 60%, I don't know. But I know it's probably definitely probably less than 80% I should have been expecting. Have a look at a couple of the examples now. Thank you.